Okay, so this question was based on electric fields. And the first thing is it said, what is meant by electric field strength? So the equation for electric field strength was E is equal to F over Q. So in this case, it's the force per unit charge, and that scores you 1 mark, but it's a 2 marker. Okay, so we always say that it's the force per unit charge acting on a small positive test charge, okay, for our second mark there. The next one was saying if we place an electron at X and is released from rest, draw on the diagram the direction of the force acting on the electron due to the field. So if we think about these field lines are clearly moving in this direction, so they're moving towards this area, okay? And field lines always go away from the positive towards the negative, so they're moving towards a negative, away from a positive. So then we're looking at where the electron might be moving. Well, the electron's going to move away from the negative towards the positive, so the force of the electron has got to be acting in that direction, okay, due to the field. So we have it drawn to the left in this situation. The next part of the question was a little bit more tricky, and this was the description one, and it was worth 4 marks. And it says the electron is replaced by a proton, which is also released from rest at X. Compare without calculation the motion of the electron to the motion of the proton after release. So you may assume there's no frictional forces acting on them. So if the electron was moving to the left, okay, the proton will be moving to the right because they have opposite charges. So as long as you said it was moving to the right or opposite to the electron, that was going to score you 1 mark in there, okay? They initially are experiencing the same amount of force, okay? But when we look back at it, we can see that a proton, okay, is actually going to move where the field lines are getting closer, and then the electron is going to move where the field lines are getting wider. Okay, so that's something to bear in mind. We need to discuss those in a little second. I put a little star here because I forgot to write it down. So sorry. Because they're initially receiving the same force, initially the acceleration of the electron is going to be greater than that of the proton, okay, because the proton has more mass, okay? So if we think like F is equal to ma, if the F is the same but the mass of the proton is greater, its initial acceleration is going to be less, okay? Whereas the electron, it's got a smaller mass, okay, it's got the same amount of force, so its acceleration is going to be initially greater, and I'm saying initial here. Now, the proton's moving into that smaller field, okay, so it's entering a stronger field, so therefore if it's entering a stronger field, there's going to be more electric force then acting on it, okay, so then the acceleration of the proton is going to increase, all right, so you get a little mark for recognizing that. Recognizing that the electron then is weaving into a weaker field, we can see that because the lines were spreading out, okay, meant that the electron was going to decrease, or the acceleration, sorry, of the electron was going to decrease. Okay, so you kind of got another mark for recognizing that. You got a mark for explaining the initial, and you also got a mark linking into the idea that the field's getting stronger and weaker. So there was lots of different marks you could get here, but most people kind of only stuck with this first one. So these ones are a little bit harder, a little bit more difficult to think about, but when it's talking about motion, you usually think about in terms of, is it going at a constant velocity, is it going to be accelerating, is it going to be decelerating? And in the case of fields, look at the field lines, okay? Are they getting stronger, are they getting weaker? And that's going to help you with answering questions similar to this. All right.